Dear students, welcome to another lecture in machine design, elements of machine design. Today we are going to discuss a topic called ergonomics of design considerations. Ergonomic considerations of machine design. Ergonomics. This may be for the first time you must be hearing ergonomics. You see, the word ergonomics was first coined in 1950 by Human Research Society of United Kingdom, and it was later designated as the Ergonomic Research Society. The word ergonomics is coined from two Greek words. Ergon means work and nomos means natural laws. Therefore, ergonomics means the natural law of work. So, what is ergonomics? Actually, here the definition is given. Ergonomics is defined as the relationship between man and machine and the application of anatomical principles, physiological principles, and psychological principles to solve the problem arising from this relationship. You see, we are having always man and machine combination. If we have to ride a motorcycle, if we have to use a motorcycle, there is a machine and there is a man. These are in a relationship there. What is the relationship between these two? The study of this, it comes under ergonomics. So man is and a machine. If you are driving a truck, there is a man and there is a machine. If you are operating a control system, there is a man and there is a machine. Most of the machines, unless they are fully automatic machines, they are man machine systems. Even your washing machine is a man machine system. A man is needed to operate the machine. So any machine you take, there is a man associated with it. Okay. So the relationship between man and machine. If you are operating a computer, here there is a man and a machine. If you are operating a phone, mobile phone, there is a man and a machine. So the relationship between these two, the study of this using anatomy. Anatomy means Sharira Rachana Shastra, how the body is made, how the structure of the body of a human being is, and a physiological, that means Sharira Shastra, that means how the body functions, and psychological principles, that means Manas Shastra, see about the psychology of human beings. Some things he may like, some things may please him, some things make him angry, like that. you know Such things are all psychological. See, sharir rachna shastra, sharir shastra और मानस शास्त्र, ये तीनों का कॉम्बिनेशन में इनका उपयोग करके आदमी और मशीन के बीच में जो संबंध है, जो संबंध के बारे में जो पढ़ते हैं हम, उसको अपन एर्गोनॉमिक स्टडी बोलते हैं. ठीक है. सो नाउ from the design considerations, you see here, the main objective of ergonomics is to make the machine fit for the user rather than make the user adapt to himself. You see, you remember how when you were studying in kindergarten, first standard, second standard, how small your chairs and tables were. Now how big they have become. Because your body started growing, you became big. Similarly, your chairs and other things became big. The cycles that you were using in small, when you were small, when you are 5 years old, 6 years old, how small those were. Now the cycles that you are using, how they are. You see, we have to what the designer no or the ergonomics aims to decrease the physical and mental stresses of the user. Can you not now sit on a table that you used in LKG or first standard? Yes, you can use, but the thing is you won't feel comfortable there. So what happens if you are not comfortable? If you are not comfortable, your body will be experiencing unnecessary stresses, and even your mentally you will be feeling unnecessary stresses coming. See, our aim is if you are making anything comfortable, that means what? Physical strain, physical stress, and mental stress you are reducing. That is how a machine should be made. You see, in the beginning, in the old days, when they started studying this machine design, this study of ergonomics was not part of their studies, but now it is become essential. For design consideration, the areas of ergonomic studies are as follows: the relation between man, that is the user, and the machine, and about the working environment where these two are placed, and the human anatomy and posture while using the machine. Posture means, in what position the man is when he is using that machine, whether standing, sitting, or in whatever position he is. The energy expenditure in hand and foot operations, and how much of energy we are consuming as a human being in operating that machine. So these are the things that we are going to consider. Okay, first let us come to man machine relationship. So any machine cannot continue working for a long period of time without any human being. Okay, so work can be performed by a man machine system. You see, there can be fully automatic machines. See, fully automatic washing machine is there, but still a man is needed to operate it. We are having fully automatic CNC machines, but still, after some time at least, a man should come and operate. Okay, hence a man machine system may be defined as a combination of activities between man and machine and get the desired output from the given input. You see, uh, any machine, you know, any machine takes some inputs and gives some outputs. And for this man machine system, you know, this is being used as a combination of activities between man and machine. Okay. In other words, ergonomics considers man-machine joint system forming a closed loop. You see here, you see there is a figure here. On the left side, you see a uh, man loop, and this is machine loop. You see, first what? Information reception. Information is received by the man, whether by looking through the eye or by hearing some sound or something, and by looking at that, man can take a corrective action. For example, a red lamp has lighted. Okay. Oh, man understood. Something is wrong. Maybe the petrol in the motorcycle is reducing, or if it's finishing, or it's almost finished. Then he has to take some corrective action. He has to fill the petrol or something. Okay. Suddenly, something, no, he is saying, I'm going the motorcycle. Okay, and then suddenly a old lady is crossing the road. He has to take a corrective action. He has to apply the brake. Then what he does, he applies the brake. That is the machine control. And then this machine immediately it slows down, and this slowing down, this information is fed to man again. Okay, then he whether he sees whether the old lady has passed over, sorry, crossed the road, and then he takes a corrective action. Now he says, okay, now you can remove the foot from the pedal and you can go forward. Okay, this is how man machine system works. So this man machine closed loop system This has the working environment. It has lighting, noise, temperature, humidity, and air motion. All these things form working environment in which they are working. Okay, this is the man machine system. Then from display instruments, as the operator can get the information about the operation of a machine. Suppose you are working on a CNC machine. Suddenly a red lamp burns. That means something is wrong. The machine is saying some problem came. Okay. If he feels that the correction is necessary, then he takes the corrective action to operate the control or lever. Then the man sees, and if he sees, oh, it is abnormal, some action should be taken, he pulls some lever or some presses some control or something. This corrective action, it alters the performance of the machine. Whether you have to stop the machine, you have to slow the machine, or what you have to do, you will do it, which will be indicated on display panel. Again, if the machine has done something, it will display. Suppose you have braked on the motorcycle, your speedometer will, which was going at 100 kilometers per hour, it may come down to some 30 kilometers per hour or something. The display is seen in the speedometer, like that. The contact of man machine system in a closed loop system arises at two places: information display instrument, which gives information to the operator, and control, which will be operated by man to adjust the machine. See, instruments, display system, information display of the instrument, that shows us, for example, as I told you, when you are braking, the speedometer speed is reducing, maybe from 100 kilometers per hour to 30 kilometers per hour. You are seeing that. And how the man has done it. Man has put his foot on the brake, and the accelerator he has reduced. These two things he has done. And when that old lady has crossed the road, then when there are no more obstructions, again you can increase. You see, now again you can release your foot from the brake pedal, and then you can increase with the hand the accelerator, and then you can see the instrument display, display of the information that the speed is now again increased from 30 kilometers per hour to more. Okay, next we will see design of equipment for control. You see, when we are designing the various equipments for controlling the machines, we have to design in such a way that they are after the ergonomic considerations. Okay, see, suppose a graduated dial. Graduate dial means a dial in which numbers are written. Some markings are there. Or a display. That means that which shows some signals. Or a signal to indicate the response of the machine to instruction. Okay, the type and size of the control devices selected depends upon a number of factors, and these are the required speed of operation, in what speed you should operate the machine, required accuracy of the control, whether you require accuracy or not, the required operating force, how much force you have to apply, and the direction and movement of on, off, or increase or decrease. You see, if you are operating an accelerator, you know which direction if you rotate it will accelerate, in which you rotate it decreases. And similarly, when you are applying the brake, in which direction you press it will be applied, in which direction you move it, it will release the brake, you know it. Okay, the required range of control, the control how much you can give. Okay, there is a range for it. See, all these are the factors um, which are depending upon the type and size of the control. Okay, see, various types of controls are shown in the figure next. Crank, hand wheel, knob, hand lever, foot pedal, push button, toggle switch, joystick, etc. You see, here there are some figures. This is a crank. You see, this is where we handle it, we hold it in the hand and we will rotate. This is a crank. And this is a hand wheel. Even there are so many hand wheels that we use in the lathe machine, we use even for steering the car as a steering wheel, and so many things. A star wheel, this is also similar to this hand wheel, only that the wheel is not there. Then hand lever, sometimes for applying brakes or something, hand brake in cars, you can know, you would have seen, it's a hand lever. Or in some of the machines also where you have to operate, you may be using hand lever. Foot pedals, you see, for the accelerator pedal, the brake pedal, hand clutch pedal, these are all foot pedals in a car. And knobs are these, like our fan regulators knobs, or these knobs that are there on your screw gauge, micrometer and all, these are knobs. Okay. And these are push buttons. Push buttons are so many push buttons. You have push buttons on your phone, on your mobile phone, on your computer, and you have push buttons even for electricity, for doorbell, and so many push buttons are there. That means if you push, it will operate. Then toggle switch means it may be on off. Once you press, it becomes on. Again you press, it is off, like electric buttons. Like if we are putting on light, press once it is on, press again it is off. Even if your mobile on off button, press once it is put off, press again it is on. Computer also, press once it is switched off, press again it is switched on, like that. Then joystick is some kind of lever with a ball socket and ball joint here. And this is used, even like you're applying gears in the car, or even for while you're playing video games or something, you are having joysticks. So these are various types of controls. And then if anything, okay, hand wheel, uh, torque corresponding to tangential force of 300 newtons to 400 newtons if the rim of the wheel grasped firmly by the hand. You see how much a human being with one hand can work. See how much weight you can lift with one hand. No, with one hand you can approximately lift some 30 kgs. 30 kgs works out in, if you convert it into newtons, it becomes 300 newtons. So 30 and some strong people may be able to lift 40 kgs of weight. 30 kgs of weight to 40 kgs of weight you can lift, and 30 kg force can be translated into 300 newtons, and 40 kg force is translated into 400 newtons. So with one hand you will be able to operate so much force. So this you should have an idea. See, earlier all the steering wheels, they were all what we should say, they were all without the power steering. Now power steering with a little force. You see, the more force you apply, the more tired you will become. Okay. Anyway, that is the hand wheel. Then small crank. The crank can be operated at high speeds with load of order 10 newtons, 20 newtons. Maximum speed of crank is 200 rpm. Handle length is 40 millimeters. You see, handle, you are in the fist, मुट्ठी में पकड़ते हैं, मुट्ठी का कम से कम वो कितना होना चाहिए, कितना लंबा होना चाहिए, कम से कम 40 mm तो भी होना चाहिए। और कितना उसका डायमीटर होना चाहिए, what should be the diameter, at least 10 mm. Less than 10 mm will be too little. Okay, at least 10 mm it should be there, and bigger, your accelerator diameter, how much is this, it may be around 25-30 mm. And similarly, how a round knob should be, what should be its diameter, and how much force should be required to operate it. Then joystick, whether it have, how many degrees of freedom it has, uh, and like suppose gearbox operating lever of a car is there. Hmm? How much, how the joystick should be, how tall it should be, and how the grip should be, push buttons, you see, car horn, maybe we are operating with the palm, and TV on off switches, we may be operating with the finger, so how, what should be the diameter of that, and everything. Okay, so next, these important things are there, the ergonomic considerations in design of control. Okay, you see, the control should be easily accessible. इजीली एक्सेसिबल मीन्स ये अभी तुमको आसानी से उसको उसके पास पहुंचने के लिए मिलना चाहिए. इजीली एक्सेसिबल, लॉजिकली पोजिशन बोले तो एक लॉजिक के अनुसार पोजीशन होना चाहिए. मतलब अगर कोई राइट हैंड से ऑपरेट करते हैं तो लीवर राइट हैंड के साइड में होना चाहिए मशीन के, और लेफ्ट हैंड से ऑपरेट करते हैं लेफ्ट हैंड में होना चाहिए. ओके, उस तरह द कंट्रोल ऑपरेशन शुड इन्वॉल्व मिनिमम मोशन एंड अवॉइड आउटवर्ड मूवमेंट. वो अभी ये मोशन मिनिमम होना चाहिए. ये हाथ बहुत, मैं अपने शरीर से बहुत दूर स्ट्रेच करने की जरूरत नहीं पड़ना चाहिए. ओके, and the shape of the control, shape, how it should be in contact with the hands, should be conformity with the anatomy of the human hand. अभी ये anatomy के अनुसार जो है, अगर बड़े लोग ऑपरेट करते हैं तो कैसे बटन होना चाहिए, ग्रिप्स कैसे होना चाहिए, अगर छोटे बच्चे ऑपरेट करते हैं तो कैसे होना चाहिए, अगर भारत के लोग ऑपरेट करते हैं जो छोटे कद के होते हैं तो कैसे होना चाहिए, अगर यूरोप के लोग ऑपरेट करते हैं जो बड़े कद के होते हैं कैसे होना चाहिए. हाँ, किसी के हाथ छोटे होते हैं, किसी के हाथ बड़े होते हैं, कोई लेडीज ऑपरेट करते हैं, जेंट्स ऑपरेट करते हैं. डिपेंडिंग अपॉन दैट you have to have the controls. Then colors also, proper color produces beneficial psychological effect. See, the controls should be painted in red color with the gray background of machine tool to call for attention. अगर कोई भी चीज डेंजर का सिग्नल का होता है तो लाल कलर में ग्रे बैकग्राउंड में किया जाना चाहिए ताकि आसानी से अपना आंख उसको उसको पहचानने को आना चाहिए. ओके, and then like that, some colors, you see, colors produce benefits of psychological effect. You see, when Microsoft are making their windows, so much research goes into what types of colors they should use for various things, how your title bar should be, how your caption buttons should be, how your status should be, how the working area should be, how the push buttons should be, what should be the size, and everything. All so much research goes into it. See, Microsoft people don't employ only the software engineers. They employ lighting engineers also. They employ sound engineers also. How the Microsoft sounds will be. That. So much research has gone. You see, some other software you may have seen, not from well reputed companies. You see, they won't be as professionally made as the things by these big corporations like Google or Microsoft or something. These people, big corporations, have the advantage of spending money for these experts also, like sound engineers, light engineers, and others. Okay, so see the colors, how much ever time you see with Microsoft Windows, your eyes will not get tired. Whereas some of the people will be making software, some of the apps also you may see, oh, they're like a bright red color or black color or something, which is not so soothing to the eye. They will use. See, with such kind of screens, we cannot work for a long time. Okay, next we come to design of display controls. Display means that which shows some information, maybe the speed, the accuracy, the sensitivity, uh, we'll be able to know by these displays. You see, there are two categories, whether it is qualitative and quantitative. Qualitative and quantitative. You see, your circular dial may be like this. This is the hot, cold region, this is warm region, this is hot region, and this needle will be showing if it is in the hot. If it is here, then it is hot. If it comes here, it is cold. It is comes here. Otherwise, it can be placed like this: hot, cold, warm. Say this indicating. Okay, it can be circular dial or it can be the straight dial, like the straight legend. Okay, and quantitative display, it can be like this: your speedometer, circular dial scale from 0 to 100. This is circular dial and this is a horizontal scale. It can be like this also. So this type of display gives the quantitative. Quantity means numbers. Quantitative measurement or numerical information. Okay, like a fuel level, how much of petrol is there, or what is the speedometer, and watches, ammeters, voltmeters. You can see like this. Whichever is convenient to human beings, you should adopt that. Okay, and here the information can be given on a display, digital display, or an analog display. Digital display means digits are coming. Analog means, like this speedometer with the this is a this one is a analog display. Digital display means, sometimes time and other things will be showing in digits, like that is digital display. Digital display gives the information directly as numbers. Analog display gives information by pointer, which indicates the position of the scale. You see, and here, okay, they have shown this is a poor type for display, this is a fair type of display. Okay, okay, maybe this 20, instead of 2030 they have given, this can be given here, and this is big. Instead of a big and large number, a small number can be put here, and this pointer is elongated. So maybe, this we will be clearly able to say with the least response time, we will be able to read the reading. That's why that is better. Okay, then ergonomic considerations in design of displays. You see, these are the considerations when how a display should be. A See, ergonomic consideration to display, the scale on the dial indicator should be divided into suitable linear scale: 0, 10, 20, 30, like that it should be divided. The number of subdivisions should be minimum. You see, you should not write 0 also, 11, 12, 13, 14, 15, and sorry, 0, 1, 2, 3, 4, 5, 6, 10, and 11, 12, 13, 14, 15, like that up to 20. All these numbers, if you are writing, in the scale, it cannot be read. So it should be minimum. If it is much, it is a long distance is there, then you can write 0, 5, 10, like that. If it is narrower, then you can write simply 0, 10, 20, like this. Okay, the vertical figures should be used for stationary dials, and a radially oriented figure should be used for rotating dials. See, for stationary dials, vertical figures can be used. Vertical figures means, like this is vertical figure. This is vertical, and this is the circular thing. Okay, or rotating dial. The height of the letters, how big the letters should be, number should be reading distance. It should be greater than or equal to reading distance upon 200. You see, how much reading distance. Sometimes, say in Hyderabad metro stations, some boards they have put the names of the stations. Okay, you see how big the letters should be. If I stand some 100 meters away and look at it, I will not know what it is. You see, it is so small. See, that is not the right way of display. Okay, see, the reading distance divided by 100 will give you the height of the letter or the font size of the letter. Okay, the pointer should have knife edge with the mirror or minimum parallax error. Okay, this video